morning. So today class we are beginning module 7, and this module is about systems of linear equations and inequalities. So the first module, module 7.1, graphing systems of equations. So our learning target, I can determine the number of solutions of a system of linear equations. I can solve systems of equations by graphing, and I can solve linear equations by graphing systems of equations, and I can use graphing calculators to solve systems of equations. So let's go ahead and talk about what is systems of equations, because we keep mentioning that. Okay, so I've written some of the vocabulary words up here so that you can look at this also. So let's look at what is a system of equations. So system of equation is a set of two or more equations with the same variables. It's called a system of equations. And the solutions are the ordered pairs. Okay, so in this course, we are going to focus on systems of two linear equations and an ordered pair that is a solution of both equations is a solution of the system. A system of linear equations can have one solution. It can have an infinite number of solutions, or it can have no solution. So let's talk about what that is. A system of equations is, it can be consistent or it can be inconsistent. So in an inconsistent system, you can see that a system of equations that has no solutions. Okay, so in this there is absolutely no solution because it has no ordered pair that satisfies both equations. So in this one, basically this applies when there are no solutions. That means this is applying to parallel lines. Okay, so when this is graphed, this is what is applying to. Okay, when there are no solutions, because we can see that those lines have exactly the same slope but different y-intercept, but there's no place where they are intersecting each other. That is why there is absolutely no solution for a system of equations that has no solution. That is why it is called inconsistent. Okay, and let's talk about consistent. There are two types of consistent system of equations. Then in this we have the independent, which has exactly one solution. So just one solution. So the consistent independent solution in this we are going to have in a graph, and this is all of course in a coordinate graph, right? So in this one, if I have a graph, okay, and let's say one of the graph, is plotted like this, and the other one is plotted like this. Guess what? This point, which I just marked, there's one place that they are intersecting, and so that is why it has exactly one solution. Where the graph is intersecting, the ordered pair is exactly the same for both the graphs. And that is the point which is the solution of a consistent independent system of equations. So there's exactly one solution. In a consistent dependent system of equation, there are an infinite number of solutions. So this is a graph which looks something like this. Okay, so I might have a graph like this. All right, of course, this is all coordinate graphing. And in the graph, I might have a line. This is going this way. Okay, with the equation. And then I have another line on the graph which is going exactly the same path. Look, Same path as the green, the red one is also going. So therefore, every point ordered pair on both the lines are exactly the same no matter which direction they're going. So that is why what's happening. This one, it has infinite number of solutions. And therefore, this is a consistent, dependent system of equations. So it has infinite number of solutions. Once again, in the first one, inconsistent, where there's no solution, those are parallel lines that are not intersecting at all. So they may have the same slope, but they are going to have a different y-intercept, and that is why they are parallel lines. And because they are not intersecting, there is no solution. In a consistent independent system of equations, there is one point where the lines are intersecting, and that one ordered pair is the one solution to that system of equations. And in the last one, there's a line going through the graph, and there's another line which is exactly on top of the first line. So they share all the ordered pairs, and that is why that is a consistent dependent system of equations with an infinite number of solutions. So let's look at this graph over here. And of course, we are going to, it's got the example written consistent system. So we know this is, a consistent system of equations. But however, let's look. Use the graph to determine the number of solutions the system has. Then state whether the system of equations is consistent or inconsistent, and if it is independent or dependent. So the first thing, let's look at this graph. How many points or how many places is this graph intersecting? This graph is intersecting only in one place, which is over here. Okay, so therefore that these two lines intersect at one point, and so this is telling me that there is only one solution. Okay, there's only one solution, and therefore the system is consistent. So this is consistent, and it is independent Okay, so once again, since it is it is intersecting at exactly one point, there's only one solution, which is this ordered pair, and so this is consistent and independent. Let's look at this question now. Use the graph to determine the number of solutions the system has. Then state whether the system of equations is consistent or inconsistent, and if it is independent or dependent. So if I'm looking at this, we can see that the lines over here are parallel to each other. That means they have the same slope, which is 1/2. But the only thing that is different is your y-intercept. So the y-intercept is different. Okay, so because they have the same slope, they have different y-intercepts, I am getting parallel lines. And parallel lines do not intersect. They go on continuously. So because they are parallel, there is no solution. There is no solution. And therefore, the system is inconsistent. Okay? So let's look at these two examples now once again to determine whether the graph is showing a system that is consistent or inconsistent, and if it is independent or dependent. So let's look at the first one. Once again, you can see that the slope is the same and just the y-intercept is different. So because of that, these are parallel lines and there is no solution, and this is inconsistent. Okay? Let's look at this one. we can see in the second one, there is exactly one point where the graphs are intersecting. So what do we have? We have one solution. So therefore, this is consistent, and independent. This is consistent and independent because there is exactly one solution. Okay? So sometimes a graph is not provided, and then you just have to look at the linear equations and figure out if there is no solution, there's one solution, or if there are infinite solutions. So the first thing that you need to do is when you are given the equations, you need to put them in the slope-intercept form, which is y is equal to mx plus b. So here, that's the first thing you need to do. And then if there is no solution, as I just showed you on the graph earlier, they're going to have the same slope but different y-intercepts. So that tells you that it is a parallel line, and therefore there's going to be no solution. It's inconsistent and there's no solution. Okay? Then, if you have the equation and you have different slopes, so it doesn't matter, at some point, because the slope is different. One may be going this way, one may be going this way. But they will intersect at some point. And sometimes what happens that a slope that is provided, it may not be, you might not be able to see it on the physical graph because the numbers may be so large. But it doesn't matter. At some point, if they have different slopes, at some point, they are going to intersect. And so those are your consistent and independent system of equations, and they have only one solution when they have different slopes. Okay, so they'll have one ordered pair which they are sharing when the lines are intersecting each other. So let's look at the infinite solutions. The infinite solutions, of course, as I showed you earlier, one line is placed right above the other. So they have exactly the same slope, and they have exactly the same y-intercept. And so same slope, same y-intercept means the lines are the same. So this is the most important thing that you need to remember when a graph is not provided, how to differentiate as to which one is which and how many solutions there are. All right, so let's look at this. And it's saying that determine the number of solutions the system has, then state whether the system of equations is consistent or inconsistent, and if it is independent or dependent. So this has already been placed in my slope-intercept form for me, which is y is equal to mx plus b. So first, let's go look at the slopes. So if I look at the slopes, what is this? Slope is the same, okay? Slope is the same. Then let's look at the y-intercepts. The y-intercepts are different. So looking at this, I automatically know that these are going to be parallel lines. And with parallel lines, we know that there is no solution. Therefore, this system is inconsistent. So once again, when I have the same slope and I have different y-intercepts, I know that that is going to represent parallel lines. And parallel lines are inconsistent. They are not intersecting at any point. There is no solution to this system of equations. Okay. So let's look at this one now and determine whether the number of solutions the system has. So as I said, we have got to place it in the y is equal to mx plus b format. Okay, y is equal to mx plus b. My first one is already in that format. So I already have y is equal to 4/5 x minus 2. My second one has to be changed into the same format. It says 4y minus 5x is equal to 9. So I am going to move the add 5x to both sides because I'm trying to put it in the format of y is equal to mx plus b, which is a slope-intercept form. So I'm going to add 5x to both sides of the equation, and I get 4y is equal to 5x plus 9. Okay, I have 4y is equal to 5x plus 9. And then because my coefficient of y is 4, I am going to divide both sides by 4. Okay, divide by 4. I'm going to divide by 4. I'm going to divide by 4. Okay, and so then I get y is equal to 5/4 x plus 9 over 4. So let's look at the slopes now. This slope is different from this slope. And we just mentioned that if the slopes are different, then those two lines are going to intersect at exactly 1 point. Okay, so we can see that the slopes are different. So the lines are going to intersect at exactly 1 point. So there is one solution looking at the slopes being different in this case. So this is going to be consistent and independent. Consistent and independent because there is exactly one solution. So now we have this one is again asking determine the number of solutions the system has, then state whether the system of equations is consistent or inconsistent and if it is independent or dependent. So the first thing we are going to do is look at this, and we can see that both of them are not written in the slope-intercept form. So that is my first step. I'm going to change both the equations to my slope-intercept form, which is again y is equal to mx plus b. Okay, in this format. So let's start with the first one. It says 4y minus 6x is equal to 16. So I'm going to add 6x to both sides of the equation, and I get 4y is equal to, and so 16 plus my 6x, and this gives me 6x plus 16, right? And then I am going to divide both sides by 4. Okay, and so I get y is equal to 3 over 2x plus 4. So my slope is 3 over 2 and my y-intercept is 4. Let's do the other equation, which is 9x minus 6y is equal to negative 24. And now I am going to subtract 9x from both sides, and I get negative 6y is equal to negative 9x minus 24. And then I am going to divide both sides by negative 6 because negative 6 is my coefficient, and I'm going to get y is equal to negative divided by negative gives me positive, and when I simplify and I divide by 3, I'm going to get 3 over 2x, and once again negative divided by negative is going to give me positive, plus 24 divided by 6 is going to give me 4. Now, let's look at the two simplified equations that we have. And we can observe that the slopes are the same. So look, let me use a different color. Okay, so look, the slopes are the same, right? And the y-intercepts are also the same. That means it's the same line, okay? That means, let's say I have a line with the same slope and the same y-intercept, and I'm going to show you with a different color, which I have blue over here. The other line is going to be exactly on top of this line, like this. So that means all the ordered pairs are going to be the same in both the lines. So therefore, this is consistent and it is dependent. There are infinitely many solutions. Okay, so therefore they are, as you can see, it's literally having the same slope and same y-intercept. So if you have a system of equations provided to you, you can solve that system of equations by graphing each equation carefully on the same coordinate plane. And we've learned how to do that based on the slope and the y-intercept, right? So every point that lies on the line of one equation represents a solution of that equation. Similarly, every point on the line of the second equation in a system represents a solution of that equation. So therefore, the solution of a system of equations is the point at which the graph intersects. So basically that means everything which is on this line is a solution of this equation, which is y is equal to negative 2x plus 1. And every ordered pair on this blue line, which is representing y is equal to x plus 4, will be a solution to this equation. And where they intersect, okay, so where they intersect, which is here in this case, all right, this is going to be a solution of a system of equations. Okay, so this is where the graph is intersecting. And as you can see in this case, where is my graph intersecting? It is intersecting at negative 1, 3. And that is the point at which the graphs intersect. And because the point of intersection lies on both lines, the ordered pair satisfies each equation in the system. Alright, so now I have given you two different equations over here, and we are going to graph the system and determine the number of solutions that it has. If it has one solution, determine its coordinates. So if I'm looking at this, I can look at the slopes, and that's the first thing I need to do. I look at the slopes. One slope is negative 2. And both of them have already been put in the y is equal to mx plus b format. So one slope is negative 2. The other slope is 3 over 5 or 3/5. So therefore, since the slopes are different, I know looking at that this line at some point is going to intersect at one point. So I know that this is going to be a consistent and independent system of equations and is going to have one solution. So just by looking at the equations, but let's go ahead and graph it. Okay, so if I look at this one, we know that this is going to go up. It's a positive slope and it's going to move right 5. Okay, so it's going to move right 5. It's going to go up 3 because rise over run, and that's my slope. And what's my y-intercept? This is 1. So my ordered pair is going to be 0, 1. And that's where the line is going to cut the y-intercept. So I have done the intervals in 2, 4, 6, 8, 10, etc. So since it's saying that my y-intercept is 1, this is going to be over here. This is 1, right? So here is where, let me do this a different color so you can see. Okay, so this one here is my y-intercept. And this line I can see my slope, so it's going up 3, 1, 2, 3, and then 1, 2, 3, 4, 5. So here's the next point. Then 1, 2, 3, 1, 2, 3, 4, 5. Here's the next point. Okay, so that's how this line is moving. And then if I'm saying this is then 1, 2, 3, 1, 2, 3, 4, 5. And here we go. 1, 2, 3, 1, 2, 3, 4, 5. All right, so here is my line. Okay, here is my line, which is y is equal to 3/5 x plus 1. Now let me go ahead and graph the second line. And I'm going to do that with, let me do with green. Okay, so looking at the second one, I know if I look at this, my slope is negative, okay, over 1. So this is going to be down 2 and 1 right. 1 right. That's what my slope is going to be. And what's my y-intercept is 14. So my ordered pair is going to be 0, 14. Because that's where it's going to cut my y-axis or intersect the y-axis. So 0, 14 is up here. Okay? And then it said we are going 2 down and 1 right. Okay, so there's my first point. 2 down, 1. 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 And here we go. And here. And here. Okay, so with 2 down and going right to 1. So I am going to now connect. And there is my line. Okay, and so I can see that it is intersecting in exactly one point, okay, which is over here. So if I look at that, this is 5, right? That is 4. So what is my solution? Is going to be 5, 4. Okay, so once again, the graphs of the lines, they intersect at the point 5, 4. And if you substitute 5, 4x and 4, 4y into the equations, both will be true. Okay, so then we can see that what is my solution over here of the system. So 5, 4 is the solution of the system. And that's basically how I just graph it. All right, so let's look at this problem now. Now I've written out 2 more equations and we are going to graph this to see if they have a solution or no solution or infinite solutions, okay? So once again, I can see both of these equations. They first need to be put into the y is equal to mx plus b format, which is my slope intercept format. And so in the first one, I can see I have got to add 3x to both sides of the equation. So plus 3x plus 3x, and I am left with 2y is equal to 3x plus 12. And then since my coefficient is 2y, so I have got to do the inverse of multiplication, which is division. I'm going to divide both sides by 2. So divide by 2, divide by 2, divide by 2. And I'm left with y is equal to 3 over 2x plus 12 divided by 2 is 6. So we can see my slope is 3 over 2 and my y-intercept is 6. So I know that this is going to be 0, 6, which is my y-intercept. So let me first go ahead and based on what I have over here, I'm going to go ahead and graph this one. So let me graph this with black. Okay, so 0, 6, and that means 0, 6, and this is my y-intercept. Okay, and what is my slope? It's an upward slope because it's positive. So my slope over here, it's 3 up and 2 right. 3 up and 2 right. So 1, 2, 3, 1, 2. Here's the next one, right? And then if I'm going downwards, it'll be 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right, and so this is my line. Okay. Now, let's do the other one. So once again, I've got to put it in the y is equal to mx plus b format. And so I'm going to go ahead and subtract 6x from both sides of the equation. And I get negative 4y is equal to negative 6x plus 8. Okay? Next, I am going to look at the coefficient. Before the y, it's negative 4. So I am going to divide both sides by negative 4. And I get y is equal to negative divided by negative gives me positive, and when I simplify this I get 3 over 2x, and then positive divided by negative gives me negative, and 8 divided by 4 gives me 2. So that's a negative 2. Okay, now let's look. My slope is exactly the same. And my y-intercept is different. So just looking at that, I know that these are going to be parallel lines. Okay, so this means my ordered pair is 0, negative 2. That's where the y-intercept is. And then the slope is the same as that, 3 up and 2 right. So let me use the color green. And it said 0, negative 2. So here is 0, negative 2. And then we are going 3 up, 2 right. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Okay, and so literally 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And so look at my line. Okay, so as you can see, those are parallel lines and they have the same slope. They have different y-intercepts. Since they do not intersect, this system has no solution. Because again, they are parallel lines, they are not intersecting. So sometimes I am given a problem like this, and it says use a system of equations to solve whatever is provided. Okay, so use a system of equations to solve negative 6x plus 8 is equal to negative 4. So when I have something like this given to me, there are certain steps to remember. First, write a system by setting each expression equal to y. So we're going to say y is equal to negative 4, y is equal to negative 6x plus 8. So that's how we are going to write it out. Okay, and so once again we're going to write a system by setting each expression over here, okay, is equal to y. And then we are going to graph the system, and then we are going to find the intersection. So based on what I just said, we are going to set each side equal to y. So here are my two equations. Y is equal to negative 6x plus 8, and y is equal to negative 4. So now I have my two equations that are set up, and both of these equal y. Okay, the next thing I'm going to do is I am going to graph it. So I can look at this one, and I know that what is my slope on this? It's going to be here. For this one, it's 6, negative 6. So I know it's going downwards over 1. So 6 down and 1 right. Okay, this is 1 right. That is this one. The other one is saying y is equal to negative 4. So no matter what x is, y is going to be negative 4. So it's going to be a straight horizontal line. Okay, so let me go ahead and plot y is equal to negative 4 first. And I am going to use, let me use green. If y is negative 4, so if x is 0, y is negative 4. If x is negative 4, y is negative 4. If x is 6, y is 6. So it doesn't matter what x is, y is going to be negative 4. Okay, so hold on, just trying to, there we go. And so this is going to be a straight horizontal line, and this one is basically telling me that y is equal to negative 4. Now let me use another color to show you y is equal to negative 6x plus 8. Okay, so I know that what is my y-intercept is 0, 8. So I'm going to go to 8 and I'm going to plot this. And this is 0, 8. Right? And then it is telling me that I am going down 6, 1 right, based on the slope that I have. Okay? So 1, 2, 3, 4, 5, 6, and 1 right. 1, 2, 3, 4, 5, 6, 1 right. 1, 2, 3, 4, 5, 6, 1 right. And so now let me connect. Okay, if I connect this, sorry if my line is not straight. Okay, here we go. Trying to make it as straight as possible. Okay, so now look, where is that intersection happening? Okay, and I can see that, look here, this is what my solution is, because it is intersecting at one point, and my x is what? What is my ordered pair? 2, and this is negative 4. 2 and negative 4. And that is going to be the solution of this system of equations. And you always want to check your solution. Check your solution to see if it is correct. Okay, you take your original equation, which is negative 6x plus 8 is equal to negative 4. Okay, and then I am going to substitute the values, and I said this is x and this is y. So I'm going to say negative 6 times 2 plus 8 should equal negative 4. What is negative 6 times 2? I get negative 12 plus 8 is equal to negative 4. So negative and positive, so I subtract the absolute values and I give the bigger absolute value. This gives me negative 4 is equal to negative 4. Okay, so looking at that, yeah, that's definitely a solution to this. Okay, and that's how we find, the x value for this graph. Once again, we are just going to make two equations. So with each of them, we are going to call y is equal to, and then we are going to go ahead and solve it. Okay. One last question, and this one is going to just tell you how to do this on a graphing calculator. It's everything we're doing, but it's going to be on a graphing calculator. So when using a graphing calculator, it is also possible to graph the lines in the equation, and you can use a graphing calculator to graph and solve a system of equations by following these steps. Of course, first thing you'll have to do is you've got to isolate the y. We've got to put it in the format of y is equal to mx plus b. So everything we've been doing so far. So we are going to isolate the y in each equation. We are going to graph the system by putting that value into the graphing calculator, each of the equations into the graphing calculator. And then we are going to find the intersection, and that is going to be the solution to the system of equations. So based on the two equations that were just given to me, as I said, I would have to isolate the y. So I put both of those in the y is equal to mx plus b format. And then I am going to enter the equations into the graphing calculator. And I'm going to hit graph, and this is what comes up. And then I can find the intersection, and the solution is approximately negative 5 and 5400 and 2 and 5200. So it's everything we have done, but just in the form of a calculator for the last one. Okay, and that's basically what this entire lesson is about. This is again module 7.1. We are graphing our systems of equations. Just remember, just by looking at an equation, I can tell whether there is going to be one solution, if there are going to be infinite number of solutions or no solutions. So once again, when they have exactly the same slope and they have a different y-intercept, it's going to be parallel lines, so there is going to be no solution. When I have different slopes, I'm going to have exactly one point where they are going to intersect, and that is going to be my solution. I'm going to have one solution when I have two different slopes. When I have the same slope and the same y-intercept, we are going to end up with infinite solutions, because it's literally two lines which are together and they will have all the same ordered pairs that they are sharing. So that's how, just by looking at an equation, we can identify, or by looking at a graph, we can tell whether it is consistent or inconsistent. And that's what module 7.1 is all about. Have a great day, everyone.